Many engineering challenges involve large or very complex problems. So for example, imagine designing an airplane or a deep water drilling rig or a piece of telemedicine equipment. So if you think about these challenges and the number of pieces and parts, it can become overwhelming really quickly. So let's explore this idea a little bit farther by thinking about designing a new college dormitory. So I want you to think about the type of spaces you might have in a college dormitory, the types of uses or activities, and finally the types of users that would be in the college dormitory. So take 2 minutes and jot down some ideas for these spaces, uses, and users. So in terms of spaces, you might imagine dorms or areas where students sleep, or a cafeteria, or common meeting spaces or public restrooms. For uses, you might think of sleeping, or studying, working with a computer, eating, having a meeting, or having a party. And then for users, you might think of the students, a resident associate who might live at the college, the janitors, or the cafeteria workers. So you can quickly see that designing a large or complex design space can become unmanageable. In fact, you'll see that there are a large number of variables with a large number of values, creating what seems to be an infinite space. So decomposition is the process of breaking apart a large, complex design problem into smaller, manageable chunks. Decomposition can be an effective tool when large projects can be separated into moderately or modestly independent parts. So for example, thinking about the dorm, it might make sense to separate out designing the dorm space where the students would sleep from, say, the kitchen where the cafeteria workers were preparing the food, because one doesn't necessarily impact the other. However, it wouldn't make sense to separate out the dorm space from the hallway right outside the room because you're using the same real estate in making those decisions. Decomposition succeeds when large projects can be separated into discrete project blocks. These project blocks must be doable by an individual or a small team, and the project blocks are more effective when they can be done fairly independently from one another. Decomposition also makes effective use of teams. This way, individuals or teams with expertise can do work that's well aligned with their skills. So for example, you might have a team that's well suited to design a kitchen space and a team that's more suited to work on the dorms themselves. Decomposition fails without synthesis. It's important for teams to coordinate their decisions, and it's also critically important for teams working on these large projects to communicate with one another. So designing a college dorm will probably not be your first engineering assignment, but the idea of decomposition can still work very well, even for smaller projects. So consider the design of a toothbrush. Take a few seconds to think about the pieces and parts of a toothbrush. So the parts of the toothbrush you likely identified included the bristles, the handle, and then something to connect the bristles and the handle. So even for designing a fairly simple object like a toothbrush, the process of decomposition can be helpful because you have a team that specializes in developing and designing the bristles and a team that specializes in the handles. So it's fairly easy to think about the physical parts of a project when you decompose it. What may be more difficult is to think about the functions that a product needs to have. So let's take the example of toothpaste. So I want you to think about some of the functions that a toothpaste needs to have, and then when you want to design to include the chemicals that supported that toothpaste. So most toothpastes include a number of chemicals, such as those that prevent tartar buildup on the teeth, that include fluoride to prevent tooth decay. Some toothpastes have an agent that tries to reduce bad breath. Some of them have a whitening agent. And finally, some have an anti-gingivitis, which helps improve gums. So the idea of decomposition can be very useful for prototyping, for decision matrices, and for brainstorming. Decomposition can be helpful for prototyping when the design has fairly discrete pieces or parts. This allows a team to prototype, build, and test their parts separately. This may allow you or your team to go faster. So decomposition can also be helpful with decision matrices. We're going to be talking about decision matrices in a few videos, But just know that decision matrices are a structured method to sort through and select promising ideas. So in some cases, it can make sense to use decision matrices on decomposed parts of the project. This can really streamline the decision-making process. And finally, decomposition can really help with the process of brainstorming. Having decomposed parts of a problem can facilitate directed creative thinking. Decomposing a project during brainstorming will likely result in more ideas, although few of those items will be fully formed. So if we think back to the toothbrush, and you spend time brainstorming, you can brainstorm bristles, you can brainstorm the handle, or you can brainstorm the connector. Again, using this idea of decomposition and brainstorming can help you think of more ideas, although again, they may be less fully formed. Fortunately, there is a tool for that called a morphological chart, and we'll be talking about that in another video. So in summary, the process of decomposition supports engineering design teams in taking these large, complex problems and breaking them down into manageable pieces and parts. Once a problem has been decomposed, engineers can readily tackle that project to find a successful solution. Decomposition really only works, though, if there's good communication among the teams and a complete synthesis at the end of the project.